Hi everybody. Alright, so this is your review for your exponents test. I'm probably just going to go over the evens, and I'll post the answers to the odds if you'd like to try them. Okay, so number 2. I'm simply raising this base to the exponent of 3. So the rule is you distribute the power to each of the terms on the inside. So I'm going to go a little bit slow here just to review the steps. So negative 3 gets raised to the third, x to the negative 1 gets raised to the third, and y to the negative 3 gets raised to the third. So now in the calculator, type in negative 3 to the third. Okay, you should get negative 27. Now when I raise a power to a power, the rule is I multiply. So x to the negative 3. Again, I'm going to multiply the negative 3 and 3, and I'm going to get y to the negative 9th. Now, the direction says that your answer should contain only positive exponents. So that means any exponents that are negative, like this guy and this guy, need to be brought downstairs. Now this coefficient is negative, but it doesn't move. The power of this coefficient is 1, which is positive. So I'm actually going to move just these two pieces downstairs. So my final answer is negative 27 over x to the third, y to the 9th. Okay. Number 4. I'm multiplying this term by this term and this term. But before I can multiply, I have to do order of operations. So what that means is I'm going to have to square and cube this first, or distribute those powers in. So again, I'm going to go a little bit on the slower side. So negative 2 is going to be raised to the negative 2 power, and then b squared is going to be raised to the negative 2 power. I can bring this middle term down. It says negative a squared. Just to make my life easier, I'm going to make it negative 1a squared, b to the fourth, times negative 2 to the third, and then a to the third. So distributing those powers in. So again, before I can simplify anything, I may want to do something with these parentheses. So I know that I can do negative 2 to the third. I know that's negative 8. I know I can write a to the third as a to the third, and this is negative 1a squared b to the fourth. That's not going to change. I know I can multiply these two exponents, so that's b to the negative 4. But is negative 2 to the negative 2 power a positive 4? That's the common mistake. So what I'd like everybody to do right now is pause the video and type this into the calculator just the way you see it, with parentheses and everything. And I guarantee you, you're not going to get negative 4 or even positive 4. Okay, so you should have gotten 1 over 4. That should have been your answer. So let's leave it as just negative 2 to the negative 2 power. And we'll treat this like this is a negative exponent, and we'll bring them downstairs. So I'll bring this down, and I'll keep these on top. So I'm going to write it as negative 2 to the positive 2, b to the positive 4. So I brought both of these negative exponents downstairs, keeping both of the bases. I kept the base of b, I kept the base of negative 2. And now this I'm going to put up here, but I think I'm going to multiply it while I'm here. So negative 1 times negative 8 is positive 8. A to the second times a to the third, I add the powers there. So that's going to be a to the fifth, and then b to the fourth. Now I notice these b to the fourths are the same, so they can cancel. And I can put now negative 2 squared in the calculator, or think about it, what's negative 2 times negative 2? And the answer is 4. So 8, a to the fifth, over 4. Now I can divide 8 and 4, which gives me 2. So 2a to the fifth. Final answer. Okay, let's go over number 6. So number 6 is x squared y to the negative 4 over this. I cannot divide until I simplify this first. So let's rewrite the numerator as x squared y to the negative 4. And now let's distribute that power for the denominator. So this denominator is technically like a negative 1 squared and a y to the negative 1 squared. So again, rewrite the numerator. And now the denominator. What is negative 1 squared? You should be saying positive 1. And y to the negative 1 squared, I'm going to multiply these, so y to the negative 2. Okay? Now, the other problem that I did, I flip-flopped the negatives. Like I would bring this up, bring this down, but I'm just going to do this in a different way, just because I can. I see this as a subtraction because I'm dividing, so I can subtract negative 4 and negative 2. So it's negative 4 minus a negative 2, which means negative 4 plus 2, which is a negative 2. So when I subtract these, I keep the base, and I have a negative 2 for the power, and I have the x squared. So now, if I want to write it with positive exponents, I just bring the y squared down. And that's it. Okay, let's move on to the last question, which is a little bit more challenging, and it has to do with fractions. Okay, so the best way to tackle this problem, again, is to use PEMDAS, and is to take care of this stuff first. So I'm going to write it out, and first I'll leave the m to the negative 5/3 and p to the negative 2. And I'm going to now multiply negative 1 and 3/2. So actually, let me just write this over here. M to the negative 1 to the 3/2, and Q to the negative 1/3 to the 3/2. So we're going to multiply negative 1 times 3/2. So that becomes M to the negative 3/2. That didn't change. And now Q. So in the calculator, or without, multiply negative 1/3 and 3/2. You should get negative 1/2. Pause the video through this if you need to double check my algebra or my math, okay? Now all of this over m to the 2/3, p to the 4/3, okay? So it looks like all of these things have negative exponents, so all of these can go downstairs. So really this is 1 over, it's going to be a long thing here, we'll leave the m squared to the 2/3, and what's going to join this m to the 2/3? These two m's. So let's write them. M to the now positive 5/3, m to the positive 3/2. Okay. Now we have this p to the 4/3. What's it going to be joined with? This p to the negative 2 that I'm bringing down. Okay. And I'm also going to bring down this q to the negative 1/2. Okay, so I'm almost done. My final answer is going to be 1 over. So I have these 3 m's that I'm multiplying together. What do I do with these 3 powers? I want to add them. Same thing with the p's, and then we just tack on the q. So we can go ahead and put the q there, q to the 1/2. Oh, I just realized when I brought these down, I didn't make them positive. These should have positive powers. Alright, so pause the video, add, and then add these two, and then tell me what you get. Okay, so for the power of m, you should have gotten 23 over 6, and for p, you should have gotten 10 over 3. Okay, so this is your final answer for that fraction problem. Okay, now let's review how to change exponents to radicals and radicals to exponents. So if we want to write down the rule would be x to the power over root is equal to the something root of x to the power. Okay, so this was the rule that we discussed. So the first thing that I'm going to do with number 10 is I'm going to recognize that this is a square root, and that's one of those common things that we talked about. Anything under a square root is the same thing as saying b to the 1/2. And I'm going to raise that to the 5th power. So again, when I raise a power to a power, I'm going to multiply. So it's 1 over b to the 5/2. Alright, so one more thing is we're allowed to use negatives here because we want to write it in exponential form, which is a base to some power. So therefore I can bring it up and it becomes negative. So b to the negative 5/2. Okay, same thing with number 4. Anything that's inside a fourth root is the same thing as saying 5k to the 1/4 power. And then I'm going to raise this thing to the third. And I'm going to multiply 1/4 and 3. So my final answer is 5k to the 3/4 power. Alright, now for number 14, I want to write this in radical form. First things first, I want to make the exponent positive. So 1 over n to the 5/3. And now I remember the number on the denominator is the root, where the top number is the power. So the answer is 1 over the 3rd root of n to the 5th. Same thing with number 16. 5 is my root, and 1 is the power. No need to make positive exponents because they're already positive. So this one is just one step. We have 3r squared, and then the 5th root to the 1st power. You don't need these parentheses because I'm raising it to the 1/5 power, so that's no problem there. Okay, let's move on to solving equations. Okay, so question number 18. We want to get this x by itself. So we have a fraction in the exponent, so that means we're going to have to raise it to the reciprocal. But before we can do that, we actually have to isolate this base of 125. So the first thing we want to do is subtract the 1. So take out your calculators, or in your heads, do 26 over 5 minus 1. Resume the video until you've done so. Okay, you should be getting 1 over 25 equals 125x to the negative 2/3. Okay, now that my base is isolated, I can raise both sides to the 3 over negative 2, or the reciprocal power. Again, anytime I multiply a fraction by its reciprocal, they're going to cancel to 1. So I'm left with 125x equals, now please put this into the calculator, you should get 125. But this is a special example where you're going to have to write plus or minus. And the reason why, again, why it's plus or minus is because I have an even number in the numerator of the original problem. So if you want to write that down, even number in numerator of original fraction means two solutions. Okay? So the two solutions go right after when you flip it. Okay? So now let's branch it off into those two equations. Positive 125 equals 125x, and negative 125 equals 125x. This one's easy. Just divide both sides by 125. So we get x equals 1, and x equals negative 1. Okay, let's move to question 20. So the first thing we want to do again is isolate the base. The base is 6 minus 2n. I'm sorry, 6 minus n. So we have to get rid of this 2 in front. So that's going to be our first step, is to divide by 2. When we divide 432 by 2, we get 216. And we're left with 6 minus n to the 3/2 power. Now my base is isolated, and now I can raise it to the reciprocal. So take a minute, put this into the calculator, pause the video until you've done so, and then hit resume. Okay, you should be getting 36 equals, these will cancel, 6 minus n. Subtract 6 on both sides. You should get 30. Divide negative 1, and you get n equals negative 30. Okay, the last one on this type of problem is 22. So the first thing I notice with this problem is that I have an even number in the numerator. So that means that I'm going to have two answers. Okay, we're going to have a plus or a minus somewhere. So first, like always, we want to isolate this base. So let's get rid of that minus 8 first. Okay, so minus 8 on both sides. You should get 64 equals 4, 3p minus 49 to the 4/5. Divide this 4 out, and we get 16 equals 3p minus 49 to the 4/5 power. Okay, now that this base is isolated, we can raise both sides by the reciprocal, 5/4. So put this into the calculator just the way you see it, and hit resume when you've finished. Okay, you should get 32, but you have to remember, like I said, because I have an even power in the numerator, when I flip it, I'm going to have a plus or minus. So it's plus or minus equals 3p minus 49. These will cancel. So my two equations are positive 32 equals 3p minus 49, and negative 32 equals 3p minus 49. And we're just going to solve both equations. So one value is 27. We're going to add 49 here. So those are your two answers. Okay, let's move on to the last type of questions that'll be on your test, which are radicals. Okay, so the first step in solving all radical equations is that you have to isolate the radical. So this radical needs to be alone on one side of the equal sign. So I actually need to get rid of both of these two terms. So I'm going to add the 3 and subtract the 5p. So subtract the 5p, add the 3. So I'm left with 5p plus 11 equals 6p minus 5p is p, and plus 3. Okay, now that my radical is isolated, I can square both sides. Now the square and the square root cancel each other out, so we're left with 5p plus 11 equals. Now, you cannot distribute this 2 in. You have to double distribute. So p plus 3 times p plus 3. So 5p plus 11 is equal to p squared plus 6p plus 9. I did that fast because I knew that p times 3 was 3p, 3p again, so 6p. Okay? So now, I want to solve this quadratic equation. I have to first set it equal to 0. So I'm going to subtract 5p and subtract 11. So I get this, 0 equals p squared, 6 minus 5 is 1, so plus 1p, and minus 2, because 9 minus 11 is negative 2. And now I'm going to factor this trinomial. I can use the AM method, so I should get p plus 2, p minus 1. And my two answers are p equals negative 2 and p equals positive 1. Okay, now this is very important that all radical equations must be checked for what we call extraneous solutions. Extraneous solutions is just a fancy mathematical term for it doesn't work out. So you have to check it out to see. And we're always going to check into the original equation. I'm not going to do the check, but I'm going to tell you that they both do in fact work. Okay? If you want to see the check, you could check the answer key on the Google Drive account. I'll have all the work there. Okay. Now, last but not least is question number 26. What happens when I can't isolate a radical? Like, there's no way. This radical is already isolated, and there's no way I can isolate them both at the same time. So when that happens, you can just go straight to squaring. You can square both sides. So the square and the square root here cancel each other out, which is nice. So 3n plus 7. Now, when I square this, there are two terms in here. There's a 4, and there's this radical. So I actually have to square the 4 which gives me 16. And then when I square this radical, the radical and the square cancel each other out, so I'm left with negative 1 minus n that I'm going to multiply by that 16. Once I do that, I can solve. So I get 3n plus 7 equals negative 16n minus, whoops, that's wrong, sorry. You should get negative 16 minus 16n, and then just solve for n. So I'll add 16n on both sides, and then subtract 7. And here's my answer. Okay? Now again, you always make sure to check, and I'll give you a hint though, this one definitely does work out. Alright, again, all the work's on the Google Drive account if you'd like to see it, but be careful because questions number 23 and 25 may not necessarily work out and check, so please make sure you are checking. Okay, that should do it for review. If you'd like to do the odd problems, be my guest. Again, check the Google Drive account and you'll see all of the answers in detail. Alright, study hard.